Welcome to EDU World Space.
Problem 8.27. So we have Rebecca and Daniel. Is it Daniel? Yeah, Daniel, who are ice skaters. We're looking down on them on an ice rink. Daniel is stopped and we're told he's tying his shoe. And Rebecca is coming towards him at 13 meters per second, and unfortunately she runs into him. And then we're told her initial speed and the direction is sort of arbitrary. We're going to put it in we're going to call that the positive x direction, and so y will be up there. And we're told their masses. And so then we're told her final speed and the angle that she makes with her initial direction. And then we need to find Daniel's velocity after the collision is part A, and then part B, we want to find what is the change in kinetic energy. So all of the components of the velocity in the plane of the skating rink have to be conserved because it's frictionless ice. So our initial momentum is just Rebecca's mass times her initial velocity. And then this has to be equal to her mass times her final velocity plus Daniel's mass times his final velocity. So then solving this for his final velocity, we find that this is equal to the ratio of their masses times the difference between her initial speed and her final speed. So now her initial speed is going to be, the 13 meters per second in the x direction, and her final speed is going to be that 8 meters per second times the cosine of the angle in the x-hat direction and the sine of the angle in the y direction. So then we find that this is going to be 5.68 meters per second in the x direction and negative 4.43 meters per second in the y direction. And if we had chosen, because we're not really told this in the problem, so we get to pick, if we decided that she was going to be going downward in this figure and he was going to be upward, then obviously, this would be positive because this would have been negative. So now we want to, this gives us the direction and the magnitude, but it's a little bit easier to think about if we have them separately. So just like for any vector, this is just the square root of the sum of the components squared. And we find that this is 7.20 meters per second. And then his angle, I guess I just called it theta d in my drawing there. Is going to be the arctangent of the two components, which if we draw a little picture here, here's the x component, here's the y component, here's theta, the opposite over the adjacent is the tangent of that angle, and so take the arctangent of both sides. And you get that. Put those numbers into the arctangent, and we find that his angle is 38 degrees. So for part B, we want to know what the change in the kinetic energy is. So the initial kinetic energy is only due to Rebecca moving, because Daniel's initially at rest. And then the final is going to be, because is going to be the sum of both of their kinetic energies, because they're both moving. And so delta K is obviously just going to be your final minus initial kinetic energies. And plugging in all the numbers and then doing the subtraction, we discovered that the kinetic energy of the whole system has decreased by 680 joules. And it's good that we end up with a negative sign, because otherwise energy would have had to have been added from somewhere, and since there's nothing to add any energy, that would have kept us up at night. So there we go. This is Daniel's final velocity, and this is the amount of energy that was lost, and we can see it was not an elastic collision.